Good afternoon. Just now you had a tea and refresh. Okay. Generally, when I give anywhere talk, no, I worry whether they will give memento, honor, or honorarium or not. Everything I have received, so I have no tension to give a talk now. They already, Anubhav already gave, sir. You take memento, sir. Am I audible? Huh? Okay. We'll start. You are coming? No, you are going there. Yeah. Okay, for the sake of easiness and comparison, if you allow, I will talk. Okay, for the sake of easiness and comparison, if we divide entire world's academic and industrial experimental work, okay, academic and industrial experimental work of the entire world's different types of work, but experimental work, into three categories based on their phases: solid state research, solution phase research or a liquid phase research, and the gas phase research. If we divide this, let's say, just for sake of comparison, any kind of research you ask me, I'll put it in these three columns. So once you allowed me this, okay, I have no hesitations to say, compared to solid state and the gas phase, solution phase research is dominant. So once I say, you need not to believe. I'll put my argument why I'm saying so. In a solid state, we usually work at very high temperature. And for me, as a physical chemist, increasing temperature means you need more energy. More energy you need means more money. More money means it's not sustainable or affordable. Gas phase research, you need high temperature, high pressure, and leakage proof. So problems are there. You have to handle more. Difficult. There are advantages, because I don't want to tell advantage now, because I want to prove I am right. Okay. So the maintaining high temperature and pressure and maintaining what you call leakage proof need more money, more time, high what you call intellectual people, and more energy means more money. More money means nobody will buy. Whereas solution phase, wherever you need dissolution, okay, what you call separation, mixing, stirring, transporting, wherever these things are involved, it is much more easier. Yes or no? It is easier. Easier is not a technical word. I will say less energy consumed. Less energy consumed means less money. Less money means economically viable. Economically viable means people can afford. So this is the beginning. ये trailer है, picture अभी बाकी है. Okay. So you like it? Trailer? You convinced or not? You convinced or not? Okay. After you convinced, let me say one problem. There is a problem. When you have a solution phase, apart from all this advantage, one biggest culprit is a volatility. They are highly volatile. So because of this volatility nature, they contribute to so many other problems: air pollution, ozone layer depletion, some other problem. So how we can retain in a solution phase and how we address this problem is all about my talk. So I'm going to convince you. Okay. So we are going to talk about a new kind of solvent. I generally say new wine in old bottle. New wine because it's a new topics, okay, but old wine because it's a molten salt subclass. Molten salts are known for centuries. Nothing new in that. They want to sit, otherwise they will ask me to go out. Okay. So let us start how this field helped to develop sustainable technologies. As what's your name? She already mentioned that I am from chemistry here. I'll not tell much. And I would like to thank all people, whomever helping. I'm only standing here on behalf of them. all my PhD students, bold means graduated, they are doctors, unbold means yet to be doctor, and all my collaborators, funding agency and this. So why I am telling acknowledgement before, whenever you say Prakruti or Anubhav says, sir, is enough, you please leave. So I will leave. So that time I may not get acknowledgement time. So I am standing on behalf of them. So I'm here last 13 years or so, 15 years over, yeah, 16. If I asked my student, hey, come all of you, whatever we did in 15 years, can you put it in one slide? So this is one of the student came up, I gave some suggestion, they modify. So we mainly work on tuning the structure to make a new solvents. We tune their structure to get the targeted property, and this we need to achieve desirable application. So we do reverse design. First we find out some application, and then we say how we can tune the property, not one property, set of properties, maybe conductivity, viscosity, refractive index, heat capacity, density, as many as possible, and then, oh, which kind of structural combination may give this, and then we synthesize them. Most of the time we are successful, sometimes not. So that is all about. So we tune the structure for the targeted property to achieve the desirable application, and we work on these various sustainable solvents, and we study their various acoustic, volumetric, transport, refractive, thermal properties as a function of temperature and pressure. We also study their equilibria with solid liquid, liquid liquid, vapor liquid equilibrium when two phases are in equilibrium. And you know, when phases are in equilibrium, how chemical potential play a key role, isn't it? That's how the entire industry is running. And we generate extensive database, and we use this data to develop the structure property or structure property concentration or structure property application correlations and reverse design. Reverse design is, I know this should be properties of my solvent. I don't know which solvent it is. Can you make it? That's the reverse design. And then I was not happy with one slide. I asked my student, can you make it one line? One line or one equation. They come up with, mathematically it is not correct, feeling wise it is correct, okay? So we work integrating fundamental science with engineering approach for socially relevant and sustainable technological developments. And I added minus infinity to plus n. There is nothing called minus. I say anything and everything we will do. We have to boost up, no? So I would like to start with this logo. Anybody knows what is this logo? This you know, this is a periodic table. This is IIT Madras logo. Okay? What is that logo? Are tukka maro. Just guess. Wrong answer is allowed. You will not be hanged for wrong answer. Yeah, United Nations Sustainable Development Goals logo. How many colors, Amma? Wrong number allowed. How many colors? Wrong allowed, Appa. Wrong. 24. Huh? 24. Good. It's a wrong answer. 8. It's completely wrong. 16 completely wrong. 19, 16 wrong. 17 is the right answer. 17 is the right answer. I have not counted because I know this next slide is 17. So, wherever you go after this, after your master or doctor or postdoctoral, whether it is a faculty position or industry position or some job, wherever you go, or you are trying to your own entrepreneurship or what you call other startup, anything you want to do, your work or your boss work or your institute's work or your company's work should be directly or indirectly contributing to any one of this. Then only your boss or your company will sustain. When they sustain, then only they will pay you. Isn't it? So otherwise, why we should worry about my company owner, whether if he is not getting profit or she is not getting profit, he may say, why you say my boss is a male only? If she is not getting profit, she will not pay you. So this is what one has to keep in mind. Need not to be a direct. So we will work mostly on responsible consumption and then clean water. This entire center is for that. Affordable energy. So there are many things for science people. All may not work. Okay. So what is a sustainable development? Any development which is economically viable, environmentally acceptable, socially equitable. This is called sustainable development. And global chemical industries keep on rising. So many chemicals are added and it is keep adding. So as a chemist or as a scientist, it's our responsibility to look for what you call no waste or least waste and reusable every time. All of you know the RRR movie, no? RRR, reduce, reuse and recycle. So most of the economies are linear economies, olden ages. Today, if it is a linear economy, your company may not get approval. At least on paper, it should be circular economy. So there is no waste. So after consumption, or it has to be reused, or it would be regenerated, or it would be recycled, or you have to close the loop. When you apply for your what you call startup, at least on paper you make sure that loop is closed. Otherwise, it will not get, straight away it will be rejected. Well, one of the author, I don't know whether he's there. Yeah, he's. Anyway, today it's a regulation that all the big companies has to put their environmental footprints on the website. It should be publicly available. Anybody wants, let's say before joining a company, you can also go through what is their footprint, whether they can survive after 10 years or not. If yes, then only you join. Otherwise, your job will be gone. Okay. So, Newton's third law. Anybody from physics? Newton's third law. So something like that. We can fight with anybody, but not with the nature. Will you fight with, let's say, you already know this guy is 10 times powerful than you. Will you take panga? Will never. Yes, do you think nature is powerful than us or not? Nature is powerful then why we are taking panga?
Correct.
We should not fight with nature. We should be friendly with nature. Because once nature start fighting with us, we will not survive. So far, nature is ignoring. Fight, F-I-G-H-T. So far, nature is ignoring us. Okay, हमारे बच्चे हैं. These are ignorant people. They don't know what they are doing. चलो छोड़ देते हैं. Next time they will. How long? How long? You see how the weather's conditions, extreme hot or extreme temperature high, extreme cold, extreme flood. This nature is not doing by intention, but it is doing by or intention, in with space and tension. Intention. Okay. So you protect nature, nature will protect you. You fight with nature, nature will fight 1,000 times than the nature. So you have to be very careful. Okay. I am worried Prakriti may say he is a comedy teacher. Not like that. It's a very serious. It's a very serious topic. Not to fight with the nature. Is it any comedy? It's a serious. We have to be. So let me go into, this was extended trailer. Okay. Now we'll go to the movie. So what we will do, why we are doing, as I mentioned earlier, I already gave this. It was a part of the trailer. So when you are looking for ideal, now you are convinced that volatile organic solvent we should replace from any kind of industry. We have convinced, let's say. Now what is the next alternative? See, as a politician you can say, hey, don't make environment, all this. Politicians can make any statement. But as a scientist or an engineer, we must provide alternative. All of us are very good at asking questions and seeing wrong things. But after asking question, do we have alternative answer to provide them? Okay, that's how one should see. So we have to, when you look for ideal replacement, okay, it may not be, there is nothing called ideal in this world. Okay, when we are looking for a match, you or your parents or in-laws, you go for matrimony, you ask all these people, the ideal list would be very lengthy. Okay, the girl should be fair but not better than me. Girl should be tall but not better than me. Girl should be educated but not better than me. Girl should be earning but not better. So many things will be there. But as time is going on, you will cross one by one. The last would be, it should be girl, it is fine. So, but what is our ideal condition? What is our ideal condition? We say very low volatility, high chemical and physical stability, high potential for recycling, should not lead to other problem, and low cost and high yield. How it is possible? Once I went with my wife, listen, it's a very serious affair. You may also go, okay? Once I went with my wife to purchase a handbag. I only know my PIN number and this one. What she was saying, the bag should look small. Of course, the company name, and I don't know all Gucci and all this thing. I say, if it is more than 5,000, PIN number I will forget, I told. Okay. So she said she says bag should look small, but it should contain many things. I say, if it is looking small, it is small only, no? It should look small, but it should hold many things. How it is possible? So, low cost and high yield and all this is how is possible. These are the guidelines. That kind of things never exist. We all try to go to ideal. So, whether it is experimental work or computational work or theoretical work, nothing is foolproof. All the way we try to go closer and closer to the truth. And that's why we validate from varieties of the techniques. Spectral, thermal, other techniques. So, different experimental techniques, different computational techniques, different theoretical and principles, and on top of that we compare with the literature. Hey, all people are saying same, so this should be the truth. That's how we do. That's what it is called research. If you do only one experiment and you want to publish in Nature, will they take? The website itself will not take. It says you cannot upload. So, when we look for a greener solvent or sustainable solvent, we have certain things. The polarity should be, I asked my student, how you choose a solvent for your reaction? Many students I ask, sir, whatever available we'll take. Why we'll go and ask sir buy new? He will ask another problem, another things. Why to go and see professor unnecessary? Huh? Okay. Anyway, people said we have to be careful with all P. P is police, P is prosecutor, P is a public when gathered in a very angry mood, okay, and the last P is very good, but still you should avoid, it's a professor. Okay, so basicity, protic and aprotic nature, all this we have to combine. When mix and match will be a problem. So one condition, two condition, no problem, but we want varieties of the condition together. I want highest rank, good job, very good girl, but I don't want to work at all. It's difficult, no? So, most of the students or most of the researchers look for polarity, or maximum they see functional group, alcohol, amine, ester, ketone, few more functional groups, ester, cyanide you don't say, okay? Acid, ketone, aldehyde, few more, ether, ester, few more.
Hexane.
Huh? Hexane is not a functional group. Alkane, nitro, iso, few more functional groups. Anything I missed? Oh, you are not from chemistry. Any more functional groups? One more? Acyl, okay. One more functional group? Cyano. Acid we told. Acid chloride, COCl. Okay. So, student will see only functional group, polarity and temperature window. So, melting to flash point or a boiling point. In this range, but these are not adequate. One should look beyond. Why you do research? Quickly, I'll just say, why you do research? Why you do research? Bolo, kahan se ho?
To solve the problem, basically.
Yeah, that is the secondary. Money. Good. Please clap for her. So, primary reason is, any of student come to my group, no, I say why you should do very good research and publish 4 papers. I give reason. Are you interested to get a good girl or very good girl as your wife? He said, yes, sir. Then you should publish more papers. I says, why? If you are publish more papers, your CV is better. So you likely to be shortlisted. You will get a good postdoc, and then you do work more because you have experienced. Okay, one astrologers I went and I say, सर आपका है ना 7 साल तक means 7 years, 7.5 years your astrology is not good. Then I was at least optimistic. After that, he said you will become habitual, sir, no problem. So 5 year you work very hard, you become habitual to work hard. You don't know what is to go for a movie and enjoy. You don't know. So you work in postdoc also, then you come back and join, then your CV is better, you will get a job. You will get a job. It doesn't matter how you look. You should have a job. So once you have a job, you will get it. Convinced? Convinced or not? Why? So coming back here, all of us we are scared of something. All of us are scared of something. This is the not chemistry, but it is a psychology. What is scared of? I am scared of stability. What could be? I don't know what is future, but I am always worried about future. Long ago, before marriage, I was worried about who will be my future wife or what. After having, I was worried why she only. Okay. Okay. So there is no time we are happy. It is happiness will never come from outside. It is inner. So we are always looking for something. We don't know what we are looking. We may be looking for high grade, better rank, and better guide, better lab, better papers, okay, better position, better job. If I put all together in one form, better wife. or we'll say we are name, fame, award, reward, promotion. These are the one we are looking. That's what we do research. This is the first shell. Now we will go to the second shell. His answer is right. Having this, you should never settle for small. Anything we do, no, it's like a business mind. Anything I should do, it should be at least 10 times I should get back. Nothing wrong in being selfish. Anybody says I am not selfish, just bluffing. Okay, nothing wrong in being selfish. I do research. What I should need? I need one paper should come. I need my student get a good PhD. The student should get a job. This paper's work should go for patent. I should get for award for patent and this paper. My student should get job, and based on this, I should get a promotion. After that, everybody should say, "Hey, you have done excellent work." Still, I am not happy. I should say this work should go to industry. They should pay me a royalty. Still, I am not happy. Based on this, more students should come, more people work. I do not work at all. Still, I am not happy. Everybody should write their papers and give it to me with my name. I only correct. Still, I am not happy. Is it wrong? Is it wrong? Is it wrong? Kuch galat hai? Huh? Okay. But to reach to that position, first you have to work. To reach to that position, first you have to work. So coming back here, we said the second one we do research because it has to be society relevant, industry relevant. So then when I say society or industry, is it a small thing? It's a big thing. When I'm working in the laboratory, I work on small tiny things, micrograms, milligrams, not kilograms, no, maximum grams. That means my research in future, it should be scaled up. Yes or no? When you scale up, so many problems will come. Let's say today I am taking 2 milligram of something and it's analytical balance, 5 lakh rupees balance, but next what you call vibration proof table, but my phone is there. Keep on notification coming, phone coming, krr, tung, 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 and up fan is running. And he says, that time only friend is calling. He said, 2 milligram, arey, 0.1 milligram here, there, not a problem. It's a problem or not? Because you are going to scale up. Have you heard any time, dushman ka dushman dost hota hai? Enemy's enemy is friend. Have you heard? Huh? Have you heard this? Now I ask, error pe error kya hota hai? Let's say density is a density. Will it work? Huh? What is density? Mass by volume. Yes or no? I take 10 ml water and I weigh. It's a 10 gram. My balance, this is what is answer 1 gram per ml or gram per cc. This is density. My balance is 0.01 gram accuracy. And I took in measuring cylinder or pipette. Pipette, you know pipette? Should not do. You have to suck with this. Suction bulb you should do. So pipette, we have let's say 0.1 ml or 0.2 or for let's say for comparison I will do 1. So 10 cancel out, 1 gram per cc is answer. What is the error? Should I cancel out 0.1, 0.1? Should I cancel out? Huh? दुश्मन का दुश्मन दोस्त होता है लेकिन एरर पे एरर कैंसिल नहीं होता है. Enemy's enemy may be friend, but error in a numerator and error in a denominator will not. See, you had a bond with acid. Your friend is running, hey, he's acid bond, let us pour base. You will burn twice. You will have acid burn also, base burn also. So, error and another error will propagate. What will happen? Error, it's called error propagation. One has to keep this in mind. So, though you may be doing tiny work at very early, so the habit of chalta hai, habit of no problem, habit of nobody is looking, it's the biggest hindrance for your success. Who cares how many people are looking? At least you know, no? Yes. What you have done. You know, no? Yes. Who cares? You know. And always that will be in your mind. Oh, reviewer if it ask. Even if reviewer ask, if guide ask, even if guide won't ask, after publishing, if somebody find out, that time only you have heard a case of retraction. After 20 years, one found retraction and the director has denied this position and he has to resign. 20 साल पहले एक छोटा सा mistake किया था. And you won't get it. You want to be director after 20 years? You have to be very, very careful, or a big position, manager or anything. It's because in scientific world, that's where corresponding author is there. It's a star author. I tell my student, I don't do anything, but I take all the blame. Star means you have to be very careful. Anyway, coming back here, when you choose a solvent, in addition to polarity, functional group and temperature window, you must see the physical and chemical properties. On top of that, when this work goes in the large scale, what are the regulation in your country? Is it available? Is it affordable? Can it be done at the larger scale? Can industry can develop this? If no, why to work on that kind of things? No way it is going to become in larger scale. In the beginning itself, we can think. Or it is banned. Let's say in some countries, some solvents are banned. Why to work on that kind of thing? For small scale, it is allowed. But large scale, you cannot do. Or large scale, it is very expensive. Or large scale, it's not feasible. You will not get environmental clearance. So in the beginning itself, we should be restrict that kind of work, if possible. Okay. Let us go forward. If you see Kamle top plot of polarity versus basicity, so these are the conventional solvent many industry use. If you see this list, 90% of the industrial solvent which are very largely used came. Of course, beyond this also there. But if you see there another profile which are environmentally better, let's say protic or aprotic, compared to this, they are better. But if you see this region, aprotic solvent with high basicity and low polarity, for example, tetraalkyl amines, it is empty here. We can't say, hey, don't use this, don't use this. That politician will say. What we should say, can you replace this with this? This is better. Maybe cost is similar or slightly expensive, but it is environmentally benign. Toxicity levels are low. Who will tell this? So we have to tell. So when you need large variety, so in industries, if you go forward, okay, I'll tell some more thing, I'll come. So this is a website free of charge, ACS Green Chemistry Institute website, where about 270 solvents have been shortlisted based on varieties of the properties. So you can search and use it for the better. This is the selection tool. It's like from the 270, you choose whatever functional group, physical property, everything you choose. But from there, the list, it will give you few and it will tell what could be, is it environmental benign or not. But only 270. Now, next this is a PPP, public-private partnership company, Chem21 European company. They also come up about 6 classifications of all the solvents here. Most of the 90% of the industrial solvents are here, if not 90, maybe 80. So, and this this is a published paper. Which journal? Anywhere it is written, Green Chemistry. Okay. And you can see based on their family and their safety score, health score, environmental score, and then they ranked. So they have given guidelines within the same family. If you are using some of the solvent which are not, let's say for example 1,4-dioxane, it is hazardous. Can you go instead of 1,4-dioxane any sol, because it is in the same ether company? But you have to see other, let's say boiling point is also better, maybe flash point is different. So is it work? So this is one way of looking, and their website is more interactive. You can put ascending, descending order. At least you get to have a rough idea. It doesn't mean that it solve all the problem. Now the problem is it's not this one. The demand for solvent is increasing very high. It's a $57 billion market, and every year 4% is increasing. And not only in India, everywhere, all Asia, America, everywhere it is, because of 3 sectors: energy, automotive, and the construction. Huge amount of solvents have been used, and no single solvent can solve all kind of problems. So it's like a mix and match. Bale, you know, bale. Based on your taste, you will take different things extra. And so ingredients are 10, but the bale can be made infinite way. Similarly, they use, instead of pure solvent, they go with binary, ternary, quaternary, and multi-component mixtures to adhere the varieties of the properties problem at a time. That means combinations are so many. When you look for sustainable solvent, our pool should be big as possible. If you want to buy one jeans pant, where you will go? If you go to one shop, you have to buy from them only. But if you go to shopping mall, let's say if you want to buy sari, go to Nagar. So many sari shops are there. One shop itself you will get many, but there are like that so many. So you have an option of choosing from the large pool. For me, I know pink means only one pink color I know. But if I ask my wife, she will tell 15 different varieties of the pink. So based on your choice and all these things, we can have a, so that means now we have to create a large pool. How to create then? We will see. That's what we told. Old wine in a new bottle, ionic liquids, or by accidentally, Paul Warden in 1914, he just by accidentally found ethyl ammonium nitrate. He said, hey, it is a salt and it is in liquid. So they used to call in the beginning liquid salts. Okay, but after that nobody done with better, and this is the man we say rock star. I fortunately met him in his office. I talked with him and all this thing. A very nice guy. Okay, inorganic chemist, and he started the new field. Okay, that Amitabh Bachchan movie dialogue, which one? One movie I say. हम लाइन में खड़े नहीं होते, जहां हम खड़े होते हैं वहां से लाइन शुरू होती है. I never stand in a queue. Wherever I stand, queue starts from there. It's not my dialogue. It's Amitabh Bachchan dialogue. Have you heard? Which movie? Diwar. Good, his memory. But dialogue hai na? Huh? So he created so many new fields. He started. He said, I will not touch the field somebody has created. And Tom Welton, he's at Imperial College. He took voluntary retirement because of health reason. He was the president of previous Royal Society of Chemistry president. His student, okay? His student. So these two people made this field very famous. So if anybody was interested to read more about this, just for information, this is the Chemical Society review paper. This is organic chemistry, but it's a good to read how kind of things. So this paper revolutionized this work, and then this paper and one book is there. I will tell that. Okay, these are the starting point. So this field or this kind of a new solvent possesses combination of unique property. He is like a hero which can act well, fight well, can do comedy also well, and good looking also. What else you need? Sone pe suhaga. So it has attributes. But Having said this one, you see, one new word I put here, hybrid salts. All conventional salts we know, let's say sodium chloride or potassium nitrate, both the ions, anion and cation, are inorganic nature. But here, one of them, preferably cation, is organic and another one is inorganic. One of them is bulky, another one is small. And one is organic, another is inorganic. They want to come together because they have interaction. They can't come together because of asymmetric shapes. So they are neither gas nor solid. This is thumb rule. That's why they and stay as a liquid. And based on cation choice, anion choice, and alkyl chain length choice, theoretically millions of ionic liquids are possible. Let's say I have 20 pairs of shoe. Now I am not wearing any one. Okay, and 20 pairs of shirt and 20 pairs of pant, provided I will wear at least one pant, one shirt and one pair of shoe, how many different way I can be ready? It's a 10th class mathematics question or 12th class probability. You're getting my point, no? So we have a large pool of cations, large pool of anions and alkyl chain lengths. So theoretically millions of ionic liquid feasible, but we don't know all of them will be liquid or not. That is a different story. You're getting my point. So our pool is infinite. You have to choose from there according to your need. What is my need? I should have all the properties of my choice. What else other my need? It should be economically viable. What is else my need? Environmentally acceptable. What else my need? It should be ease of doing. What else my need? It should sustain longer time. What else I need? Because our need will never end. When I am doing a research, I ask a student, what are your wishes? You just tell me. Except telling that I don't want to do research. Okay? Sir, I need one assistant. I say, okay, done. Sir, I need one senior. Anytime I have doubt, I will tell. I said, done. Sir, I need my slots should be very fast. I said, done. Okay, whenever I put in what you call sample, I need not to calibrate, sir. It should be auto-calibrated. I said, done. Then I say, sir, my sample is pure or not, it should give good results. I said, done. Sir, the results coming out, no, it should be in the paper format. Publishable format. I said, done. Should I do that into instrument to upload the paper? So, as the automations go up, the cost of the instrument go up. We have a calorimeters can be purchased in few lakhs or let's say few thousands or can be built, and we have a calorimeters few crores. All about accuracy, all about automation, all about ease of operation, all about sample size. So if you want to go in an industry where instruments are making, find out the worst guy who failed in all courses or never published a paper, but he has struggled for 5-7 year PhD. Ask him, what kind of your dream instrument you want? He will tell all the list and you try to do. Once you are successful, your company will become a billionaire company. We have to think in opposites persons perceive. Okay. Anyway, let's come here. I'll skip this. I asked one student, I take sodium chloride in a glass of water and mix it. I see now its ions are there and it is in a liquid form. Can I call it as ionic liquid? Answer is no. It is ionic solution because your Na plus and Cl minus ions are surrounded by H3O plus and OH minus. But in real case of ionic liquids, cations are surrounded by their own anions and anions surrounded by their own cations. Own here means from the same liquid. Okay, and that's the beauty, and that make them possess all varieties of the properties, combination of all these things, like flammability is very, very low. I don't agree non-flammable, but very, very low. Polarity is you can tune. Having said so great, somebody says, sir, can you say some two weakness? In your application will be there. What are your strength are? I can bluff. Then he say, what are your weakness? If I say I don't have any, sir, it won't work. That itself is a weakness. You think that you are the perfect person. If I say I don't have any weakness, he say that is the biggest weakness. You think that you are the most perfect guy. Nobody in this world is perfect, okay? So, what are the problems with this kind of solvent? Two problems are there. Two. One, cost is very high. Comparing, when I say high, I am comparing with organic solvent. Two, viscosity is high. What is this viscosity? Symbol pata hai? Eta. What is this viscosity? Resistance to flow. When viscosity high, there are so many problems. For a stirring, for a mixing, for pumping, for transporting, your pumps and other things and stirrer need more energy. Energy means again money. Huh? Double problem. So this is the biggest challenge with this field. But there are few groups in this world, including ours, we came up with the solution. We will not use ionic liquids completely. What is our intention? To replace the volatile organic solvent, make the world environmental friendly. But we will not stop any application. But this is a problem. If it is very expensive, who will buy? Nobody will. Very few people will buy. Okay, you may buy after 20 years, but not now. Okay, so we come up, Ohno's group from Japan, Douglas McFarlane from Australia, Robin Rogers from Alabama, USA, John Coutinho from Portugal. There are few more groups, and including our group from IIT Madras. We came up with that. Let us not think of replacing organic solvent completely. We use organic solvent. We use ionic liquid in that as an additive. We call performance additive. It would be a little bit, but it will boost the knowledge. So, we want no compromise on final product's quantity and quality, but the requirement of organic solvent should be substantially reduced, not eliminated. Substantially reduced. Is it greener or not? See, I cannot generate electricity, but every time I go from here, I see, hey, lights are, fans are on, nobody is there, I will switch off. I saved some energy that is equivalent to generating. So, amount of organic solvent required is significantly reduced by adding ionic liquids or a sustainable solvents as a performance additive, and then no compromise on final product's quantity and quality, and we addressed this problem. Ek tir do nishan. One arrow, two targets. Or ek tir anek nishan. One arrow, multiple problems, multiple targets we have achieved. How? No problem of viscosity because we are not using as a pure. No problem of cost because we are not using in the large quantity. No problem of energy requirement high because we are not using the pure. Will it work? That's what our research is. Okay. Chalo, we will go forward. Thumb rule says your cation source Lewis acidity should be low and your anion source should be Lewis basicity should be low. Resulting of this two mixture, salt will be 99.9999% liquid. This is a thumb rule. There are maybe few exceptions are there. Whereas your cation source Lewis acidity and anion source Lewis basicity both are very high, no doubt your salt will be solid. If it is mix and match, then it can be, you need to know few more things. Okay, and you can tune based on, for a given cation, you screen all anions, or for a given anion, you screen so many cations. Based on that, from completely hydrophobic to completely hydrophilic, you can make it. So the library is possible without even doing research, based on the nature of these ions, and this information is already there. Okay, so which kind of two ions can be, for example, BMIM, that means imidazolium based cation with butyl chain length, acetate is hydrophilic. BMIM, bistriflamide is hydrophobic. Pant is same, but the same pant, shirt I changed, my look changed. As soon as I wear suit, I talk very decently because With suit, we have to be very suitable. Yes or no? Otherwise, wear cap, we will become capable. Anyway, we'll go forward. You can tune the properties. And all this, so many applications, so many applications. What happened? This is the book I was talking, Mark Shiflett. Usually people go from academia to industry to earn more money. Very few people come from industry to academia because nobody wants their salary should go down. Yes or no? He is one of such guy. He was with the Dow company, but he was so excited with research. He wanted to do more and more research with students, and he doesn't want that Dow company job. He joined University of Kansas, and he's a faculty there now, and he's the inaugural editor of Journal of Ionic Liquids, elsewhere journal, Mark Shiflett. And all his works are industry relevant. You start with industry. All his works are on ionic liquid and DBT. This book published around 2022 or 2023, and he collated the data up to 2019, and he says this many industrial applications already there, and so many other applications are still under patent, so they don't want to share, but they shared with me, but not allowed to publish in a book. So more than, this is around 50 or 60, how many? 30, 57. More than this already now going on. So this is not only on paper good, not only for looking good or listening good, it has shown its potential to be industrially used. And among this all we are talking about here, performance additive. I will use as a little bit, you know, bhaji, onion bhaji. We add that white color small thing, soda. What is called that? Carbonate, bicarbonate. Yeah? If we add the taste of bhaji, if we do not add a taste of bhaji, will be different. You agree with me? Especially this weather. You eat chili bhaji, no? Potato, onion. So what is that it does? It's in very small quantity. What it does? It allows to, what do you call? Ferment also. Okay, taste is good, no? I leave it. It is a very small quantity. It shows its what you call significance. Similarly, can we use this kind of solvent in very small quantity and show its significance? Answer is yes, and that's what we call performance additive. I will try to convince. Anyway, there are anything we do research, it has to go to large scale. When you want to go to take it to large scale, it is called process and product design. In any product, what is the highest cost for? Let's say I'll give you three options. Hey, can I use this word? Huh? I'll give you three options. You have to tell me which is the most cost. One, this is the final product, okay? Our product. Any product. Okay. Before product, what we will have? Okay, start with raw material. Raw material. And then process. And then product design. And after this, all this will come: distribution, advertisement, or distribution. So many things will come, no? Retailer, agent, so many things will come, no? And we buy. Let's say this. There was some raw material. There is a process to make it. This is the product design. And this is the product, final product. It will be packed. If you give just like that, if they give, will you buy? बोले भैया इसका वो seal कहाँ है? Will you take it just like that? ये used है. The 2 rupees pen when my son goes to buy, no, he asks 200 questions. Is it grip? And the all question I understand. Finally ask, whatever I write in exam, will it be right? With this pen. So what I mean to say, the expectations of the customers are very high. To break this, it won't take me for 1 second of anger. To make this, probably my PhD, my professor designation also will not be useful. So coming back here, where the money is going more. Let's say the cost of final product is 100 rupees. We are buying, let's say as a consumer, As a consumer, I am buying a product for 100 rupees. I just want to distribute. What could be the raw material price? What could be the process and product design price? What could be the product distribution price? What could be the advertisement price? What could be? Just guess. Raw material for 100 rupees product, raw material kitne ka hoga? 10 rupees. Okay, very high. Very high. Very high. Okay. The most of the amount goes for the purification, the product quality. I didn't put there purposefully because nobody's answer will be right. It's before product, it is called quality management, or what you call, different company will go to quality control, quality assessment, so many things. There the highest amount goes. And that's the difference between Apple phone and orange phone. So when you want to go to the large scale, and here you need a process and product design, and this need lot of thermodynamic data. Sir, thermodynamics is very difficult subject. That is a different story. Who told you to love thermodynamics? But when you want to make a product, you must know. So these are the input parameters for your process and product design calculation. When I know this, I already provide them. So that's what we focus, sustainable solvent and thermodynamic. And we never see, there are so many companies are selling. Okay, but we never buy. 3 reasons. 1, they sell very expensive. Okay, 2, students should work little bit. So, that's not 2. 2, we want to make new ones. They sell only well-known ones. Why we want to make a new ones? No. With the new compound, anything you do, it is new. Say, my student bring with 3 papers, exactly last year published JPCB paper. Sir, everything is, no sir, our compound 1 alkyl chain length is extra, CH2. Everything that boy or the published in butyl, he come with pentyl. That's it. Anything you do with the new compound, let's say my cap is new. Okay, I say today this shirt I wear so many times. Oh, with this shirt, first time I'm wearing the cap. One thing is new, you can say that's where the novelty. That's what student thinks. We always eat bread and butter. Sometimes we should eat jam also. Bread, butter, jam. So it's an incremental. That's where the problem. When you don't think into the depth, we always go for incremental. And things won't come from out. It is inner. You should have an intention. Then only you should know information. Then only you should know how to implement. These are the 3 I rules. And the implementation and information are secondary. Most of the things we say, I do not have access to this instrument, I do not have access to this paper, I do not have this information, my senior is not telling, my guide is not, all these are secondary. I do not have time, I have to teach, I have to do this, and I am married, or my girlfriend is asking this. So many problems. Who doesn't have problem? Just born kid also have a problem. He says, I want milk, my mother is working there. He will cry or she will cry. If they are not coming, he will cry loud. After coming also, he will cry again. Next time, better you come immediately. Yes or no? Yes, sir. Who doesn't have problem? So, intention, or what was the first one? Interest. Interest is the most important. Okay. If that is not there, your guide, senior, father, mother, elder brother, nobody could do anything. You are the responsible for your position. Maybe your economical conditions, your environment, your surrounding might have affected a bit. But the primary reason, we will say, oh, 10th class mein science teacher never teach me well, that's why my fundas are like this. Not 10th class teacher, it's you are responsible. So, we make our ionic liquid because it is new, or we want to be new, it is economically viable, and synthesis procedure is not very difficult. It's a 1 or 2 or 3 step. It's just ion exchange, or what you call this metathesis or neutralization. But the challenging part is purified. So last 15 years, we had a library of more than 150 new IL, more than 100 known IL. So we have around 250 ionic liquids library, which we have again synthesized or first time synthesized, purified, characterized, and then studied their properties, profile, various properties. Okay. Challenging part is purification and handling. As soon as you open the vial, no, it absorbs moisture, most of the hydrophobic one, and by absorbing moisture tiny amount, transport properties are altered a lot. For example, conductivity and the viscosity. Other properties may not alter much, but they do alter. And once it is altered, whatever you do is wrong. So the best idea is to store under nitrogen atmosphere and work in a glow box, or every time you make it purify and immediately use it, and that's where it's challenging. Anyway, we'll go forward, and these are the properties we study as a function of temperature and pressure, and we generate extensive library. And with the systematic gap of alkyl chain length, let's say we keep one cation same, change few anions, or one anion same, change few cation, one anion and cation is same, change few alkyl chain length. Based on this, we make one family's library, and then based on this 200 or 300 data, we develop a new model. It is called structure property correlation in Microsoft Excel. It's not programming or anything, and we can predict any alkyl chain length low or higher side and any kind of a new cations and anions. So this is called structure property activity correlation, and this has been taken very well. Not only we did this, but we were the first one to do during my postdoc. So all those papers have been well recognized and well cited up to a level, some of them are now telling that it's a Gardas and Coutinho model, where we have in 2005 or 6 or 8 that paper published, where we have correlated density of various kinds of ionic liquid as a function of temperature and pressure with the molecular volume of a cation, anion, and alkyl chain length, and we gave a series 1 table. Even today, with that combination, new ionic liquid which has not been synthesized, and we calculate that property and we synthesize and do, it is matching with reasonable error even today. So that's the beauty of correlation. When you use the accuracy of the model will increase when you take the database as large as possible. In that paper, we have used something around 1500 data points, something like that. Okay. Anyway, we'll come up, and everywhere I put accuracy. Why? Why? Please remember, any research, when you want to quantify and present in a number, the number themselves neither right or wrong. It has to be meaningful only when you say the condition. Conditions of temperature, pressure, or purity, or atmosphere, calibration, or whatever other condition. Otherwise, data has no meaning. I can't say this data is good, or I can't say this data is bad. What in scientific things, it has to be reproducible under the same circumstances. So you never assume that your data is wrong, never assume your data is right. What you should be careful, whatever conditions I have applied now, if I apply same, let's say you are doing in Chennai, you do in Kashmir or in London or in Paris, not Chennai is Paris, Paris, France, Paris. It should be reproducible. And accuracy is very, very important. You can never eliminate error, Arjit. You can never eliminate error. We can only reduce the error. If you say my data are extremely accurate, that means you don't know what it means data. So one must put, especially in analytical chemistry and physical chemistry or any kind of chemistry, one must know what is the confidence level we are doing. By default, Microsoft Excel is 95%, 98 or 95? Don't know, 98? Anybody knows? By default, Excel calculations are 98% confident. Anyway, it is recording, so I will give both numbers, either 95 or 98. 98, I will. So, but you want to change the confidence level, you have to change the calculations. You're getting my point. So, one must know the confidence level, how you are doing, and one must know what could be the probable error. And the error can be due to many varieties: systematic error or instrumental error, human error, and the purity. My instrument is 5 crore. My instrument is 5 crore. Will it give good result if my sample is not pure? Huh? No. It has to be right, no? Okay, anyway, I'll give you one take home message and we'll close in 4 minutes. Okay, I'll give you one take home message. This is our contribution to the society or industry from our lab from IIT Madras in last 15 years. Around more than 20,000 data which is published in a reputed data journals. It has been screened by NIST USA. This was a IUPAC project. They will see whether they have mentioned calibration, whether they have mentioned confidence level, whether they have mentioned accuracy, whether they have mentioned all the parameters, and is it fitting into the large database. If yes, they will take. They will not ask our permission. They will take and put. So, if data included here means this is of world class level. This is another proof that you are doing on par with all other people across the globe. So, we are happy to share more than 20,000 data from our lab done by so many PhD and MSc students has been included here. This is bit old data, but it may be updating every 3-4 months. So, this is our contribution. Now, the take home message I want to give, one thing, our intention was not to replace entirely organic solvent, but use sustainable solvents as the performance additive, which can boost the final application, no compromise on final product quality and quantity, and want to reduce significantly solvent. This is first. Okay, this you keep in mind. Second take home message, whatever great researcher you are or your group, alone you cannot do everything. The collaborations are key. And the third and foremost important, fundamental science is the base and foundation for technological advancement. If you don't want to understand science or fundamental, you just finally want to see product, it won't happen. It won't happen. You can make a bridge without having the understanding the cement and your iron's property, how it can stick together, how much load it can take, but that bridge cannot survive. So, the fundamental science is the key for technology. Keeping these 3 key messages to take home, I will flash through few application. You can ask me any kind of application. All of them, what I am showing, either completely published or the most of the work published. So, there is nothing. You just search my name and ionic liquid, you will get all this property. Any of things is of your interest or your guide's interest or your future interest, please contact me. I think I may still here survive for 15-20 more years. So 20 more years my email will be active. Okay. So these are the projects we have done. One is Oil India Limited project, money given by Oil India 35 lakhs. My colleague from Ocean Engineering and me did project in collaboration. We published 1 PhD thesis, 4 papers, 2 patents in 4 years, 35 lakh rupees. Okay, this is the project where we wanted to the tank bottom sludge, and science what we did I will tell you. SARA analysis we got, we understood the resin, very small amount of resin holding the large amount of aliphatic and aromatic together, it is unable to reduce. Let's say some road work is going on and your new shoes put tar, what you will do? Hexane or acetone, you can slowly little bit. So that many people tried all conventional solvent, toluene, heptane, decane and all, but it is not dissolving. Okay, because of this reason, asphaltene resin is holding them. So what we have done, along with the solvent, whatever tank bottom sludge it dissolve, we say it's 0. 0 means we want to see the effect of ionic liquid. Then we added a tiny amount of ionic liquid. What are the ratios? You just see 0.1, 1 to 100. Okay, and then whatever it is enhanced, the bottom part we have characterized by IR and NMR, where aliphatic and aromatic should go down. Go down means it will go to up here, okay? And UV visible we have done here, where concentration of aliphatic and aromatic should go up. Simple science. And 0 is with solvent, this ion. So we have seen with the tiny amount about close to 65% enhancement. For me, it is tiny. When I say tiny, industry people were laughing. Sir, it's only 0.1. Laughing means I understood. Tiny compared to 1 gram. But this is huge. First, we want to show it is possible. Then we have seen that it is possible. So, how simple knowing UV visible, FTIR, NMR measurements, and we proved. We proved with UV, with IR, with NMR. It is happening. Now, the question is, and then we gave a mechanism. Maybe ionic liquid, cation or anion. We don't know, because for example, BMIM PF6, this was working. Let's say this is BMIM PF6, BMIM BF4, BMIM PF6. Cation or anion attacking on the lone pair of the resins and holding and making their interaction with aliphatic and aromatic weaker. So the remaining job is done by solvent. Solvent is in huge quantity. Ionic liquid is in small quantity. Resin is 7%, remaining 93% are aliphatic and aromatic. Then I just gave an example just for simple understanding. Let's say one very healthy student sitting on the bench in the middle, left side one student and right side one other student is holding, not allowing them to go out. Okay? He's very heavy guy, not allowing. And solvents or other students are pulling these two students, hey, come. Nobody is able to pull because this guy is very bulky. So, ionic liquid, notorious student, coming from the back and just pinching this. So, with this pinch, he jerked. Because of this pinch, he couldn't hold strongly. The other students have pulled them apart. This is just for story I told, but something similar might be happening. We need more computational study and more spectroscopy study, but our mechanism is agreed by reviewers of a PhD thesis, agreed by patent office. Close. Like this, we have so many, but I'm not going to because we are running out of the time. We have done enhanced oil recovery where interfacial tension and contact angles are key. Just by knowing interfacial tension, crude oil and water and contact angle, you can tell how we can take more crude. Okay, and that we mimicked in the lab. This is the setup. Where is gone up? This is the setup. Okay, surface tension. Now the third one, IGCAR, Indira Gandhi Center for Atomic Research, where trace amount of this radioactive material is a big challenge. They store in large amount of acid solution, where large amount of water is there and little bit acidic is there, what you call high level liquid waste. So here extracting, not to use radioactive material back, but can we make this waste in a smaller containers or smaller quantity? And storing them is also a problem. They have to go somewhere in the deep sea and put such a place there. They have to see and calculate and tell that this side even shark or other things will not come, no damage will happen. That's very expensive process. So we tried this and we showed that it is enhancing. I know I am skipping. And solar refrigeration, this is an Indo-Spanish project. Have you seen anywhere we have done alone? No. Everything is, when you do more, when you interact with more people, no, you have to be give and take policy. And that will show you how to behave. Okay, let's say my collaborators are from 4 different countries. Everybody's time zone is different, festival is different, and so we will learn how to respect each other. See, today is a holiday for me function, we don't celebrate, for me no problem. For you it is one sentence, for them it's a feeling. And that's we learn when you collaborate. How collaboration never go 50-50. It can be 60-40, 30-70, but not 99 and 1 or 100 and 0. That is not called collaboration, that's called slavery. Okay, so anyway, absorption, vapor system we have done, and polarity. You might have heard the highest polar solvent is water. We found some ionic liquids which can be much polar than the water, 30 or 40 times more polar than the water. What could be the application? This is one of our cover art, that in the polarity race, ionic liquids are winning better than the alcohols and water. And we have done as a heat transfer fluid in engine oil. Today in India, the problem is one truck will run from Delhi or Rajasthan to up to down, or from Tamil Nadu to Jammu Kashmir. In a 2 or 3 days, the temperature or the weather conditions are extreme hot, extreme cold, extreme rain. So how this engine oil or how the tires take care? This is a big research. So abroad research will not work here because they do not have this much extreme conditions. And that's how engine oils, this kind, we have showed that other than viscosity, we solved all the problems compared to conventional, because but that is the biggest challenge. But this shows you can have as an additive. Okay, what you call dye-sensitized solar cell, aqueous biphasic system, changing waste into value-added product, Camlet top lot. I'm just seeing last one. What do you call this? I'll not talk about CO2 absorption, supercapacitor electrolyte, cyanide sensing, pre-treatment of biomass, micropollutant from water. All of them are liquid based extraction. So you have down one liquid, mostly water, above one liquid, mostly water. In one phase, you have a conventional salt like KCl, NaCl, KNO3. In another phase, you have ionic liquids. After this 4 component, out of 4, water is common. So after 3 component, you take your waste, and from one phase to other phase, value added products are changed. What is the beauty here? Everything is aqueous phase. Second thing, everything at atmospheric pressure and atmospheric temperature. Third things, you will put back this again and reuse. So cost is only the energy for shaking and weighting and all other things. So it can be mostly economically viable. This is called aqueous biphasic systems, very famous. Among the liquid-liquid equilibria, it was known earlier for polymer and solvent. Okay, you might have studied upper critical solution temperature, lower critical solution. Once you make a phase diagram, you find out the minimum concentration required to go from one phase to 2 phase. What, similar to Clausius-Clapeyron equation you might have studied. Yes or no? Yeah. So that's based on that we use many things, but let me highlight this alone. We want to extract e-waste from metals from e-waste. Today, so many companies, so much research is going on. Most of them are hydrothermal, means pyrolysis, means very high temperature they use, and they use harsh chemicals. We want to do in a solvothermal method, in a solution phase, where at room temperature. We are succeeded, and a couple of results are there. Let me go my last slide. Yeah. To conclude, research is multidisciplinary, collaborations are needed. Fundamental science is the base for the technological development. Coming back to my topic of ionic liquids, strengths are you can tune based on cation, anion, so you can have the properties of your choice. I know I have not taken you through detail, but this you can learn. You are most intelligent people. Weakness are the cost and the viscosity, but both the weakness we have attacked by using them as a performance additive. Opportunities are plenty because pool is very large, millions of ionic liquid possible, and based on the choice of the ions or the ion sources which are benign, is likely to be benign. The resultant ionic liquid should be likely to be benign. And the threat are how many times you will use it and the energy required for reusing or recovery. So most of the people now, we are not going for recovery because that is more energy intensive. Anything you want pure, that is the most challenging. If you want to expect great friendship from not good people, it is our fault. To have a great friendship, we need to have a great people. to need to have a high impurity, it would be a more energy intensive, more expensive. So we do need highly pure compounds. We do need compromise between the energy requirement and the purity. So this is where we are trying to solve the problem. We want best compounds with the dead cheap price, to put it in a crude way. This is all about research. Research is a business, life is a business, and being a selfish is not at all a problem. Thank you.
We are running late.
Yes.
So we are cutting the Q&A.
By the way, I'm afraid of questions, that's why I took more time.